The group 18 elements. The group 18 elements means that is inert gases or noble gases. They are called helium, neon, argon, krypton, xenon and radon. So these are called noble gases or inert gases. They are chemically unreactive. So here all the noble gas like helium, neon, argon, krypton, xenon occurs at the atmosphere. The radon is a radioactive element. Here the abundance in the atmosphere dry air is there is approximately 1% by volume, which argon is the major constituent. Helium and sometimes neons are found in the minerals of radioactive origin. Example pitch blende, monazite, silicite, like this. So the main commercial source of helium is natural gas. Xenon and radons are the rarest elements of the group. So radon obtained as a decay product of the radium. This radium 226, that isotope is 226, to form radon. That is 222 radon, that is 86, and helium 4. This is the important here. We can see electronic configuration, ionization enthalpy, atomic radii and electron gain enthalpy. We will discuss here. First, electronic configuration. The electronic configurations are they attain the noble gas configuration. With the electronic configuration means valence cell electronic configuration or outermost electronic configuration. The general one is ns2 np6. Here the p orbitals are completely filled. S and p orbitals are completely filled. So in helium, only in the case of helium 1s2, that is the exception. The rest of the elements all are ns2 np6 type. So here the p orbitals are completely filled and the s orbitals are completely filled, so that they are inert, chemically inert. Here the ionization enthalpy. The ionization enthalpy is the electronic due to the stable electronic configuration, these gases exhibit very high ionization enthalpy. So ionization enthalpy is high, that is very high ionization enthalpy. However, the decreases down the group, increase in atomic size. Ionization enthalpy is decreases down the group and increasing in atomic size. Then atomic radii. Atomic radii increases down the group with increasing atomic number. Down the group increases with increasing atomic number. Electron gain enthalpy. The electron gain enthalpy, this noble gas have, that is they have a stable electronic configuration and they have no tendency to accept the electron, and therefore they have a large positive values of the electron gain enthalpy, because outermost electrons are completely filled, so that they have large positive values of electron gain enthalpy. Then the physical properties. The physical properties of the say group 18 element, that is noble gases are monoatomic, they are colorless. The noble gases are colorless, odorless and tasteless substance. This means that they are sparingly soluble in water. Sparingly soluble in water, and they have very low melting and boiling point. The reason is the type of the interatomic interactions in these elements is weak dispersion force, that is our London forces. So here the helium has the lowest boiling point, that is 4.2 Kelvin. Here then it has an unusual properties of the diffusing through most commonly used in the laboratory materials such as rubber, glass or plastics. The chemical properties of noble gases, already I said, they are chemically inert, that is because of the reason is what? completely filled outer electrons. That's mean helium having 1s2, so outer electrons are completely filled. Rest of the elements like neon, argon, krypton, xenon, like this, they are ns2, np6, so they are completely filled outer electronic configuration. And the second reason is they have high ionization enthalpy, and they have more positive electron gain enthalpy, so they are chemically inert. That's why they are chemically inert. And the reactivity of the noble gases has been investigated occasionally, that is even ever since their discovery, but all attempts to force them to react to form the compound but unsuccessful for quite few years. In 1962, the scientist, that is Neil Bartlett, Neil Bartlett, he is from University of British Columbia. It's observed the reaction of the noble gases. That is the first he prepared the red compound, which is formulated O2 plus PtF6 minus. He then realized that the first ionization enthalpy of the molecular oxygen ionization enthalpy is 1175 kilojoule per mole. This is identical to the xenon. Xenon is what? The ionization enthalpy is 1170 kilojoule. So here the similar to oxygen and xenon, the ionization enthalpies are 1175 kilojoule per mole, and this is 1170 kilojoule per mole. So he made efforts to prepare same type of the compound with xenon. See, that is the preparing this xenon with successful prepare another red color compound, like the name is, that is Xe plus PtF6 minus. This is by mixing of platinum hexafluoride and xenon. So it is a red in color compound. After this discovery, a number of xenon compounds, mainly with most electronegative elements like fluorine and oxygen, have been synthesized. So the compounds of kryptons are fewer. Only the difluorides like krypton difluoride has been studied in detail. That is, compounds of radon have not been isolated but only identified. That is, radon difluoride with the help of radio tracer technique. There is no true compounds are argon, neon, or helium are yet known. Then xenon fluorine compound. Xenon fluorine compounds. Xenons form three binary fluorides like xenon difluoride, xenon tetrafluoride, and xenon hexafluoride by the direct reaction of the elements under appropriate experimental conditions. Like we can prepare, that is xenon gas react with fluorine gas. Here xenon is the excess of form. Then the temperature is 673 Kelvin and 1 bar atmosphere, 1 bar pressure. Then they form xenon difluoride. This is a solid form. Then the xenon gas, that is ratio is changes. Xenon gas react with 2 moles of fluorine gas. Here the ratio is 1:5. 1:5. So the temperature also changes here. The temperature ranges 873 Kelvin and 7 bar. The pressure is 7 bar. They form xenon tetrafluoride. Then xenon gas react with 3 moles of fluorine gas. That is, the ratio is 1:20. 1:20 ratio. So the temperature range is 573 Kelvin and 60 to 70 bar pressure. They form xenon hexafluoride solid. Here the xenon hexafluoride can also be prepared by the interaction of the xenon tetrafluoride and dioxygen difluoride at 143 Kelvin temperature. This is the reaction. Is XeF4 react with the dioxygen difluoride. The temperature is 143 Kelvin. So you can get xenon hexafluoride and oxygen. Then the xenon difluoride, xenon tetrafluoride, xenon hexafluoride, all are colorless crystalline solid, and they sublimate readily at 298 Kelvin. That is, it undergoes sublimation 298 Kelvin. They are powerful fluorinating agents also, and they are readily hydrolyzed even by traces of water. For example, xenon difluoride. Xenon difluoride hydrolyzed to give xenon hydrogen fluoride and oxygen. See, the 2 moles of xenon difluoride react with, this is solid, react with water or traces of water to form xenon gas. 4 moles of hydrogen fluoride aqueous and O2 oxygen gas. Here the structure of the 3 xenon, I will draw the 3 xenon compounds. That is, it obtained from the we can study it from the VSEPR theory, that is valence electron pair repulsion theory. We can use, that is xenon difluoride, xenon tetrafluoride, xenon hexafluoride, like this, xenon oxyfluoride. That is, we can see the structure also here. The xenon fluorides are react with fluoride ion acceptor to form a cationic species, and fluoride ion donor to form a fluoroanions. So here, that is xenon difluoride react with PF5 to form a complex, that is xenon F plus and PF6 minus. Then xenon tetrafluoride, then antimony pentafluoride to form the complex like this, xenon and SbF6 negative minus. Then hexafluoride, xenon F6 hexafluoride MF. Here they react with metal like sodium, potassium, rubidium or cesium. That is group 1 element to form M plus and XeF7 minus. The example reaction we can write here: XeF6, take a sodium fluoride to form Na plus XeF7 minus. Then xenon oxygen compounds. Xenon oxygen compounds, that is hydrolysis of the xenon tetrafluoride and hexafluoride, water gives xenon trioxide. That is xenon tetrafluoride and undergoes the hydrolysis. There is 12 moles of water to form 4 moles of xenon and 2 moles of xenon trioxide plus 24 moles of hydrogen fluoride and 3 moles of water, oxygen. Then xenon hexafluoride, that is XeF6, react with water, 3 moles of the water molecule to get xenon trioxide and 6 moles of hydrogen fluoride. The partial hydrolysis of the xenon hexafluoride gives oxyfluoride, that is the xenon oxyfluoride. For example, the reaction is xenon hexafluoride react with water. This is partial hydrolysis to form xenon oxytetrafluoride. simply xenon oxyfluoride and react with then gives hydrogen fluoride. Similar way, xenon hexafluoride, 2 moles of water to form XeO2F2 and 4 moles of HF. Here the xenon trioxide is a colorless explosive solid. This is highly explosive solid and pyramidal molecular structure. It's a color, and the xenon oxytetrafluoride is a colorless volatile liquid and has a square pyramidal molecular structure. I will draw the structure here. For xenon difluoride is a linear, XeF2 is a linear, Xe, the structure will be, they have a 3 lone pair of electron, and xenon tetrafluoride is a square planar difluoride. The tetrafluoride is a square planar F. This is a square planar structure and this is a linear structure. The xenon hexafluoride gives a distorted octahedral structure like this, distorted octahedral, and they have one lone pair of electron also. And the xenon oxytetrafluoride, XeOF4, they have like this, xenon, the fluorine atom like this, and the one oxygen atom is, they have a double bond and lone pair of electron. This is having a square pyramidal structure, and this is a distorted octahedral. And the xenon trioxide is a pyramidal structure. Oxygen, so they have a double bond O and the double bond O. So they have a pyramidal structure. This is xenon trioxide. Then uses of the inert gases is, helium is a non-inflammable and light gas. So to use in balloons, like filling balloons, meteorological observation, and gas cooled nuclear reactors. Then the liquid helium, that is a cryogenic agent for carrying out the various experiments at low temperature. So in spectroscopic studies, so like that is in deep sea divers, they can use that helium gas. Then neon is the discharge tubes of fluorescent bulbs. Then argon used as a inert atmosphere in high temperature metallurgical process. Then welding of metals or alloys, filling of electric bulbs like this. So these are the uses of the group 18 elements. Thank you.